hash damping and password cracking happens so frequently, so it's a separate discipline, yeah, in and by itself. So it requires more attention. Let's focus on that for some time more, and let's start from this difference between the older hashes, landman hashes, and NT landman hashes, right? So first of all, landman hashes are case insensitive. So no matter what case you use in order to type in your password, if you use the same letters in the same order, it will result in the same hash value. Okay, and TLM is more secure in this regard. If you change the case, the hash becomes completely different. So if you change the case of one letter, for example, and this is much more secure because the amount of entropy generated in the hash value in this situation is much higher. Okay, as well as case sensitivity increases the amount of entropy and results in higher security. The larger alphabet of possible input values, yeah, input characters, results in higher security. So landman, for example, uses only 142 letters in its clear text alphabet, and TLM uses old Unicode char set, which is 65,536. So again, this is in many times more secure to use NTLM than LM hashes. And maybe the most significant flaw in initial LM design is that it limits the effective length of a hashed value to only 7 characters. Yeah, this is a tremendous flaw that results in absolute LM hashes insecurity. Okay, so every time you enter a string into Windows, yeah, into Windows utility that creates an LM hash and stores it in some database, the program splits your entered value into 7 character chunks, and then if the last chunk is shorter than 7 characters, it just adds some padding, yeah, and it hashes all these chunks separately and then concatenates the values. So what you need to do is to take this hash, split it into these hash chunks, yeah, and reverse each of them separately and then concatenate the clear text, which is much easier to do cryptographically than taking the whole hash and trying to reverse it as a whole. Okay, so LM was insecure by design from the very beginning, and it took Microsoft a long time to first implement NTLM version 2 and then migrate all the services and all Windows distributions to using this by default, and actually forcing use of NTLM v2 hashing algorithm in all of its products. What are the specifics of using Active Directory domain and for our purposes of hacking into Active Directory domains? So what is basically Active Directory? That is a centralized management and control organization, yeah, of a bunch of Windows machines. Yeah, so you can imagine that as some administrative domain where a bunch of people is assigned different roles in order to control, manage, operate, update, fix, reinstall, and so on, all these different machines that are included into this domain. Because doing that in this organized, centralized manner is much more simple yeah, because you can automate everything in the single point. What it adds to the picture is this single point of failure, right? So compromisation, the compromise of this domain controller, or normally there is at least two of them, yeah, or there are a bunch of them, but by default you have to create at least a primary domain controller and the secondary domain controller in order to be able to, I don't know, reboot one of them and don't have all of your domain fail and stop for this period of reboot, because when the domain controller is not available, anything that is not hashed locally in the systems should not be resolved. Any password should not be verified centrally on the domain controller. For example, when you're trying to connect somewhere, you will just be rejected for the reason that you cannot be given the permission. The authorized party in this interoperation cannot do that. It's offline. How is it organized? So Active Directory domain controller holds this LDEP catalog. This is like a tree of different objects containing other objects, and there are groupings among them, and you can imagine that as a large organizational chart of a company or a department or a local branch that contains all information about who can do what. So it's more of an authorization mechanism than authentication mechanism. But for example, NTLM hashes are most probably, I do not remember the specifics, but they are at least referred, yeah, so there are references to them. They are stored in some databases on domain controllers, but there are symbolic links to those places in LDEP catalogs that hold all the technical information, all the Active Directory domain schema, okay? And there is this service that implements authentication. What it does, it's called Kerberos. It's common. It has different implementations throughout different architectures in Unix, Linux, and so on. And in Active Directory, what it does, it basically provides you the means of centralization of authentication process. So every time a user tries to log in, either locally to a machine or remotely to a server or a specific application service, it does not provide the credentials to the system directly. Yeah, instead, the system redirects the user to the domain controller, and the domain controller asks the user for authentication credentials, verifies them, and gives the user the ticket. Yeah, so Kerberos ticket that contains like a certificate that the credentials of the user are verified and applicable for this specific use he is trying to use them for. Yeah, so then user is redirected back to the target system and presents this ticket, and the system says, okay, you are allowed to let in to get in and perform all the required operations. So for some period of time these tickets are cached. Yeah, so users are not going to Active Directory controller and provide credentials for a ticket all the time they need access. Yeah, so the system, the target system, for some period of time, it just remembers that information. And this is called sessions caching, right? So once you're in, even if the domain controller goes offline, or even if this particular system goes offline or goes to another network and you still want to connect to it, yeah, so if you are a part of the domain but you go home and want to work on your laptop over time, yeah, so you just type in your login and password, and it is verified locally by just checking whether this session is still valid. It's configured by different parameters in the Active Directory group policy, for example. Yeah, so this is there. Yeah, and this can be dumped from there. Okay, a little bit more of that later. For now, let's check out what password hacking principles are there. Yeah, so first of all, as I said, there are online and offline approaches to password cracking. Yeah, so you can either do that interactively and online, and very, very slowly. Yeah, depending on the protocol and the functionality limitations of the server. Or you can dump that from SAM databases or RAM. Yeah, if it's cached, it's most probably somewhere in the SAM database. If it's if the system holds the credentials, holds the means for verification of credentials locally within it, it's in the SAM database. But if it's still in action, right? So the sessions you are trying to get a hold of are still active. Yeah, so there is some information in the memory that can be grabbed from there in different ways. For example, by using Mimikatz or WCE, right? What do you do with that after you grab the credentials, you grab the hashes? So you have to somehow remove, reverse them. Yeah, so remove the cryptographic interference between you and the clear text data you want to get from there. So there is this very clever technique of time memory trade-off, yeah, called rainbow tables. So what it is, it is really effective. So you can do that brute force, like, yeah, so brute force manner means that you just take the alphabet of all clear text values. Yeah, so you know that clear text can contain these specific characters, and you try to combine all them together in different combinations and hash them using the hash algorithm that you know how it works. Yeah, and then compare the results with the results you have grabbed from the systems. This is called brute force because this is what it is. Yeah, you're trying to do that in a very dumb way. Yeah, so direct application of processing power without any optimization. What is rainbow tables? It's really clever and it's quite sophisticated. I will try to explain it in this way. It's like getting the idea of there can be a really large number of different combinations of all these characters that are within the clear text alphabet. Okay, so there is a really large number of values, virtually infinite number of them, because we can produce the text of any length to feed into hashing algorithm. And there is actually a limited number of hash values, because what hashing algorithm does, it takes the data of variable length, and its purpose is to produce the data of a fixed length out of it. Okay, so hash values are always of a specific length. Yeah, so SHA1, for example, produces 40 characters, yeah, of hashes. So this is mapping a lot, like infinite number of combinations of data inputs into a limited number of results. So even theoretically, it is intuitively clear that there is a way to optimize that. Yeah, so rainbow tables do this calculation of all possible hash values without actually giving you all possible clear text values, because basically what you need to recover is any clear text value that results in this hash value. Okay, so once given that, you can type it into the system and it will let you in even if it's not the equivalent of the password that has been initially provided by the original user. So this is how it works. And the rainbow tables, they basically get the advantage of this time memory trade-off, yeah, that there are unlimited number of possible clear text values, but actually you have to create only one value per hashed value in order to be effective in this process. So for different lengths and for different alphabets, there are different rainbow tables. Some of them are openly and freely available. Some of them are commercially available. There are even services that you just type your hash in and they either start cracking that, or they provide you already calculated result that was previously known from some other user, for example. So this is rainbow tables. The tools, just to remind you that there is John the Ripper, there is Windows Credentials Exporter, there is Mimikatz program, a relatively new one, very clever, and it allows extracting all types of interesting information from memory, including passwords and hashes. There are Metasploit framework post modules that do that, and there is this volatility framework, which is kind of cool too. It's basically memory forensic tool. So what memory forensics is, let me remind you, that is getting different tips and different hints from digital data about what's going on in the system in a particular time. Yeah, so what forensics normally are used for crime investigations, but in our case, volatility allows us to, for example, dump all the contents of the memory of the RAM to the disk and then process that disk as if we have direct access to a snapshot of machine's RAM in time. Okay, so this is kind of cool, and this allows us to process all this otherwise volatile information in a way as if we could access to this could have access to this snapshot for a really long period of time. So we know that now the system administrator is interactively logged in. Yeah, so we catch this moment, we do the memory dump, and we then take it back home, take it to our mothership, to our machine we control locally, and then do all this analysis in order to recover administrator's password.